Welcome to episode 2 of the Inventory Remake 2023 series. In this video, we'll work on some basic preparation for scripting the inventory itself, create some sample tools of various types that we'll use to test throughout the videos, and script the opening and closing of the inventory. Now, let's get to the video. Getting started, we'll head to the GUI we made last episode and we'll turn off reset on spawn so that we can keep our local script in starter player scripts and don't have to worry about updating the GUI variables. To keep things simple, we'll rename the local script to just client and add a module script inside of it called inventory client. We'll then do the same thing with server, calling the regular script just server and inserting a module script called inventory server. In the local script, we'll require the inventory client module we just created. Then we'll use a fancy for loop getting starter GUI at the top of the script to loop through everything in starter GUI and wait until it's loaded into the player's player GUI. We'll also need to get the player's service at the top as well and define some of the player variables. Finally, we'll add a while loop inside our for loop that repeats every time it detects that there's no descendants by the name of the GUI object in starter GUI and simply wait until there is. This loop will allow us to wait for all GUI to load before actually starting the main module script, so we don't have to use any wait for childs when getting the GUI variables. Then we'll run the function inventory_client.start, which will now head over to inventory client in order to actually add. In this module, we'll get the player service as well as the starter GUI. Then we'll also get replicated storage in order to require the modules that are there. Finally, we'll define those same player variables from the local script. Now we'll require the modules mentioned, as we'll be using them later in the script. Now we'll go through and create variable references to a bunch of the different GUI objects that we'll want a reference to, such as the GUI itself and the hotbar and inventory frames. We'll create a table to store a list of all the hotbar slots in order that we can loop through and access later on. I accidentally added a slot 0 twice, but I'll fix this later. At this point, I also realized that we need to require the inventory client module after waiting for the GUI rather than before, as requiring it causes it to run the code and create the GUI references right when we require it. Back in the inventory client module, we'll create some more of our favorite things, variable references to GUI objects. Make sure to include the item info frame, the item name text, item description text, and the equip and drop buttons. Finally, we'll create a variable called inventory client, which will essentially be the module itself that will be returned to the local script, and we'll give it the start function we called earlier. In this function, we'll use starter GUI and set the default backpack to be disabled. Heading to the server script, we're going to set it up similar to how we set up the local script, but without all the extra stuff, as the server doesn't really have anything it needs to wait for, like the GUI. We'll require the inventory server module and run the .start function. In the inventory server module, we'll define services such as players, replicated storage, and server storage, which we'll all use later. We'll then require the same modules that we required in the inventory client module, signal and janitor. Finally, we'll create the inventory server table the same way we did with the inventory client module and add a .start function to this one as well. We'll also create a .playerAdded function which will run whenever a player joins the game. In the .start function, we'll loop through all current players in the game, running the .playerAdded function for them in a task.spawn. Then we'll connect the .playerAdded function we made to the .playerAdded event itself to account for future players that join as well. Now we'll create another function called .characterAdded, which will connect to whenever the player's character is added into the game using the same method we did for the player, running it for the current character if there is one, and then connecting it to the player.characterAdded event to account for future characters when the player respawns. We'll add some print tests to make sure the code works, and then we'll test the game. As we can see, we have an error in our inventory server module, but at least the player joined text appeared above that. The issue is likely in the character added portion, and sure enough there's a simple typo in where we connect the .characterAdded event. We'll run it again and see that it works. If we reset, we can also see that the just spawned prints again, confirming that it works. We'll then head back to the inventory server module and create a table inside the module called all inventories, which will contain the inventory data for all the current players in the game. At this point, I also removed the character added portion I just made, but I'm pretty sure I'll add it back in later. Then, in the player-added function, we'll index the all inventories table with the player and set it to a new table, which will be that player's inventory data. Inside of it, we'll create a table for the inventory, the hotbar, and the equipped armor data, in which we'll add a head, chest, and feet slot, setting them all to nil for now, but just keeping them there for reference later. We'll then also create a max stacks variable at the top inside inventory server and set it to 20 so that players can have no more than 20 stacks in their inventory, which we'll code into the system later. We'll then create a table for the max amount of items that can fit into a stack for different item types that we'll create, such as weapons, armor, consumables, and resources. Disabling the local script so we can use the default backpack again, we'll now create some test tools and essentially define the layout for what a tool in this inventory system needs to look like. We'll create a sort tool giving it a description and an image and then inserting a part into it called handle, which will be necessary to test it. We'll then create a folder in service storage called all items, which will store the sample items for each item the players can have in the game. This will be important later on with loading the data for each player, as we'll copy the tools for each player from here. We'll then select the sort tool object and add an attribute called item type, which will be a reference to the max stacks data we made earlier and will be used to determine various things about that item and what it can and can't do. We'll then duplicate this tool using Ctrl+D and call the new copy helmet, giving it a different image and description and changing its item type to armor instead of weapon. We'll then create chestplate and boots objects in the same way. We'll finally create a health potion, which we'll set to be a consumable item, and a rock, which we'll set to be a resource. We'll then select all of these items and add a new Boolean attribute called isDroppable, which we can toggle off to make so players can't drop certain items. We'll set this to be true for all of the items, but then we'll create a special item called event item, for which we'll set isDroppable to be false. There is a property that tools already have, known as can be dropped, but turning that to true would allow players to drop items by using backspace, but we only want to allow players to drop items through our specifically coded system. We'll then copy all of the items from the service storage and insert them into Workspace so that we can pick them up and test if the inventory detects them being added. We'll make sure CanCollide is on for all of them, just so they don't fall to the ground, but we'll turn it off once they're picked up by a player later on. We'll also paste the items into Starter Player just to have them right away and see if they work in the default backpack. Now that each item is unique with its own image, description, and part color, we'll re-enable the client script and get started on making our own inventory system. In the inventory client module, we'll add a function called open to open the window. We'll then create variables in the inventory client table to define where we want the open and close positions for the inventory frame to be. Lastly, we'll make a debounce variable to stop any major bugs from happening if you spam the inventory button. In the open function, return if the debounce is true and then set the debounce true while we open the window. We're going to rename the function to setWindowOpen, as that allows us to do opening and closing in the same function with a Boolean argument. If our toSet parameter is true, then we'll open the inventory, otherwise we'll close it. We'll set the position to the closed position to start, then we'll make the inventory visible. We'll run the tweenPosition function and tween the inventory into the open position with whatever easing style and direction you choose. In the closing portion, we'll simply tween the inventory to the closed position with the in direction this time instead of the out, and then we'll wait for that to complete and set the inventory.visible to false. At the top of the script, we'll define user input service and create a function called inputBegan, which we will connect to the user input service inputBegan event. We'll return if GameProcessEdEvent is true and then check if the input key is whichever key we want to open the inventory with. We'll also add a variable to the module to determine whether or not the inventory is currently open. We'll add a task.wait of 0.5 seconds in the inventory opening code to wait for the inventory to open and then set isOpen to true, and in the closing portion we'll set isOpen to false after the inventory frames.visible is toggled false. Then, when the user presses the open key back in the inputBegan function, we'll run the setWindowOpen function with the argument not_InventoryClient.isOpen, which will always be the opposite of whether or not the inventory is open, allowing us to make the inventory key act as a toggle for the inventory. In the start function, we'll now connect the user input service.inputBegan event to our inputBegan function in InventoryClient. Finally, we'll run it to test the new code. As you can see, we can now toggle the inventory open and closed using that button. At the top of the code in InventoryClient, we'll make sure the inventory and info frames both start with .visible set to false, even if we have visible set to true while editing the UI before testing. Now we'll add a text button inside the inv and hotbar screen GUI in order to open and close the inventory, as well as I forgot to make one in the first episode. I'll add a UI aspect ratio constraint to make so it's square, adjust the font as I like, and then add a UI corner setting the corner radius to the max to make the button a circle. I'll then turn on text scaled for the button to make the text so that it fills the whole button, and I'll change the text color to white and the background color to black. Then I'll add a UI padding to give some room along the outer edge of the text button. I'll name this new button InvButton. In the inventory client module, we'll create a reference to this button called env-b. Then we'll connect it to the same setWindowOpen function we made earlier, toggling it just like we did in the inputBegan function on the .mouse button one-click event of the button. When we test it, we can see that the screen button functions in the same way as the keybind we made, allowing mobile users to also open the inventory. Thanks for watching episode 2 of the Inventory Remake series. We didn't get too far into the actual functionality of the inventory, but I promise it'll get more interesting soon. I hope you enjoyed the video, and I'll see you next week.